Hey, in this video, I do a very short review on limit, continuity, and partial derivatives of function of two or more than two variables. Okay, so the first problem is about limit. Uh, they ask us to find the limit of x plus y over x to 9 plus y when x y goes to 0, 0. So we know limit of function of more than of two or more than two variables is very different from functions of one variable. So for function of one variable, you can approach to a point from both sides, right? So you have only two directions. But for function of two or more than two variables, you can approach to the point, from different directions. So that's why it's a little bit different. And if in this case, right, so we just say the limit of this function is and equal to some number L, suppose, right, suppose equal to L, that is if and only if when the norm, the distance from this point to 0, the norm, let's say distance from x and y and then to 0, 0, less than epsilon, or let's say I will write very short, goes to 0, implies that uh, x plus y over x to 9 plus y minus 0, minus L goes to 0. So this is about limit of function of multiple variables. So in this case, I'll say we can imagine that, for example, if you choose to approach 0, 0 along x-axis, right? Along x-axis, that means when y equal to 0, means y equal to 0. So from here you can see this limit just reduced to limit of x over x to 9, right? When x 0 goes to 0, 0. And this is just limit of 1 over x to 8, x 0 goes to 0, 0, and that is infinity, right? That's infinity. But if we approach 0 along y-axis, means x equal to 0. Then you just plug x equal to 0 into this function, you get y over y, right? So our limit becomes y over y, xy goes to 0, 0, and that is just 1. You see, we have limit of these functions, are different when you approach 0, 0 by different directions. So that means the limit does not exist. Okay, so remember, for function of one variable, if the left limit and the right limit are equal, so the limit exists, right? And in here, if the limit along all directions are equal, so the limit exists. But of course, we cannot consider all directions. And here we just say, yeah, the limit does not exist because when you approach 0, 0 along x-axis and along y-axis, you get different limits. That's it. All right. So let's move to the second question. Consider continuity of x and y equal to x to 6 minus y to 6 over x cubed plus y cubed when x and y not the origin, right? And equal to 0 when x and y equal to 0, 0. So again, right? The function is continuous if the limit exists at that point n equal to the function value. So that means in order to, if we want to prove that this function is continuous at 0, we need to show that the limit of this function is equal to 0 at 0, right? So probably you can guess, right? The limit of this function is equal to 0. I just a quick guess, because you can see the power in here of x, right? On the top is 6, and here is 3. and the power of y on the top is 6, and here is 3. So basically, when x and y goes to 0, probably this function goes to 0. That's my guess. But we have to verify that. Okay, let's verify that. We see, but we can see that based on following observation. You can see x to 6 minus y to 6 over x cubed plus y cubed. This is less than or equal to, I would say, x squared plus y squared, s squared. That is enough for me. That's enough for me. We can see that easily. Why? Because here is when you just expand this, right? You get x squared, you get x4 plus 2x squared, y squared plus y4. And then you multiply, you use cross multiplication, you get x cubed and y cubed in here, right? X cubed with x to 4 is x to 7. And x cubed, y cubed with y4 is y to 7. And then everything in here would be greater than x to 7 plus y to 7, which is greater than this guy. I mean, that is enough. Makes sense? So I can write x to 6 minus to 6 less than or equal to x cubed plus y cubed, x to 4 plus 2x squared, y squared plus y to 4. Let's see. So if we want to see that this limit equal to 0, don't forget about this picture. X is 0, x and y, right? The distance x and y to 0, 0. I mean the norm of the distance, which is square root of x squared plus y squared. If this distance goes to 0, it implies that f of x minus L goes to 0. So that means L is the limit of x, right? F of x and y. So this is what I just wrote you here in the previous example. So since x squared plus y squared goes to 0, x squared plus y squared goes to 0. You multiply this, also goes to 0. So that means everything in here goes to 0. Okay? So that means the limit of this function is equal to 0 and equal to function value. So the function is continuous as 0. Okay? You still have another question, another function, but instead of 0, they write 15, right? So, of course, the limit of this function is equal to 0 when x and y approach 0. So that is different to the function value. This function is not continuous. So correct answer for that question is f is continuous everywhere, but g is continuous everywhere except 0, 0. All right, next question, we move to partial derivatives, right? Question 3, you have f of x and y equal to ex, e to x and y squared. And the point is ln 4, 2. They ask us to evaluate partial derivative at x and partial derivative at y. So we know partial derivative, right? So partial derivative of x is the derivative of this function when you consider y as a parameter. So you don't care about y, right? It's just a number, a parameter. So you take the derivative of this, you get ex y squared. And if we want to evaluate at this point, so you just plug ln of 4 and 2 into this, and you get e ln of 4, 2 squared, which is 4 and 4 equal to 60. Similarly, you can find partial derivative with respect to the y. That is e to x and then 2y, right? And then you plug ln of 4, 2 into this derivative. You get e ln of 4 times 2 times 2, again, which is 4 times 4 equal to 60. That is question 3. So you can solve this for, I guess, 1 or 2 minutes. Next question, find the slope of the surface in the y and the x directions at some given point. Find the slope in x and y direction. So hx and y equal to x squared minus y squared, and then the point is -1, 2, and -3. It's strange, right? That means in this we don't have z, but we consider this is function of 3 variables. But what is the slope of the surface in the x and y direction? That is nothing but partial derivative with respect to the x and with respect to the y, right? So basically, you need to find h with respect to x, h with respect to the y, and that is 2x, that is -2y, and then you plug x and y into this, you get slopes of the surface in x and y direction. So I think you can finish yourself. Next question, find the total differential. Total differential. So your function is z equal to f of x and y. The total differential is equal to fx dx plus fy dy, right? So basically, in order to find total differential, you need to find partial derivative with respect to the x and with respect to the y. That's it, right? So let's say the function is e2 negative x, tangent of y. So from here, I can write fx is equal to negative e2x tangent of y, right? And f with respect to the y equal to e2 negative x. And then derivative of tangent is secant squared. So it has secant squared y. You plug this and this into this formula to get total differential. Okay? So it's easy. Next, the chain rule. The chain rule. Okay, let me solve quote. W equal to psi of x minus y, where x equal to t squared and y equal to 2. First question, they ask us to find the w with respect to dt, right? By using the chain rule and then by using just normal way, when we plug x and y into this function, we get function of one variable, like calculate 1, right? So, but what is the chain rule? Chain rule say if you want to take the root of this with respect to this guy, right? Here I think cosine of minus y, okay, minus y. So that is partial derivative of w, right? With respect to the x times dx over dt, and then partial derivative of w with respect to the y times dy over dt. And that's it. Basically, you need to find the partial derivative of w with respect to the x. What's that? That is negative psi of x minus y dx dt. Here is x, right? So dx dt is equal to t. W partial derivative with respect to the y, I get negative psi of x minus y. But we need to take the derivative of the inside function with respect to y, right? So that is negative 1 times dy with respect to dt. It is scalar, so derivative of y just 0. So the second term is 0. It's very simple. That is negative 2 t psi of t squared plus minus 2. Minus 2. Okay? That's how we can use the chain rule. And if we want to use calculus 1, so you plug x and y into this function, you get w equal to cosine of t squared minus 2. And you use the chain rule for function of one variable. You can write dw dt equal to the chain rule. You take the derivative of the outside function, which is negative psi, and then t squared minus 2 times the derivative of the inside, which is 2t. So see, they are the same. And the last question is also about the chain rule. But for partial derivatives. So you have function w equal to psi 7x plus 8y x equal to x plus t, no, s plus t, okay? And y equal to s minus t. And they ask us to evaluate s when s equal to 0 and when t equal to pi over 2. All right, I just saw one, and other things you do yourself because that is very similar, okay? So we have dw over ds by the formula. So the difference between this problem and the previous one is when you plug x and y into this function, you get a function of two variables, right? In the previous example, you have function of one variable, but x and y are functions of two variables. So that's why here we use partial derivative. So we have almost the same formula for this, but that is dw over dx, and here dx over ds. Here we have partial derivative, right, of x with respect to dx. Here w over dy, then dy with respect to dx. So what is the derivative of w with respect to dx? That is 7 cosine 7x plus 8y, right? And then the derivative of x with respect to the s is just 1. Plus, here I take the derivative with respect to the y, I get a cosine 7x plus 8y. And then multiply by the derivative of y with respect to the s, that is 1 again, right? In order to evaluate that, I just, we can just calculate x and y separately and then plug x and y into this. Or you can plug everything together. But you can do that. Let's say x equal to 0 plus pi over 2. Y equal to 0 minus pi over 2, right? So from here I can get 7 cosine of 0 pi over 2. That is 7 pi over 2 plus 8 times negative 2, negative pi over 2, right? Plus 8 cosine of 7 pi over 2. Oh, almost the same. Interesting. No, it's a. Oh yes. So what do I need to do that? So 7 with a is 15, right? 7 with a is 15. So I just don't write this, and I write 15 in here because 7 and a is 15. Yeah. And then so just 15 and you 7 pi over 2 minus 8 pi over 2. That is negative pi over 2, right? The 15 cosine of negative pi over 2, and that is 0. So I'm done with the practice quiz. I hope this review is helpful for you.